So far, we've only talked about the sine and cosine functions. It turns out that there are actually a total of 6 different trigonometric functions that we're going to work with. And it turns out that these other 4 that we haven't talked about yet can all be determined using the same setup that we already have. So remember, we have a point x, y, and once you have that point, you have a distance r from the origin to that point, and that line segment creates an angle theta in standard position. And our sine theta value is y over r, cosine theta is x over r. All these other 4 functions are just other relationships between x, y, and r. So tangent theta is y over x, cosecant theta is r over y, secant theta is r over x, and cotangent of theta is x over y. Now it'll take some time to get used to saying those names, but with a little bit of practice, it'll be pretty easy. Now when we look at these relationships, initially we can start to look around and see some reciprocals. So for example, that's a reciprocal, that, and other relationships like that. But the ones that we're going to focus on right now are actually relating all 4 of these new functions back to just sine and cosine. And all this is just a little bit of algebra. So let's take a look. Tangent of theta. Tangent of theta turns out to be sine theta over cosine theta. So let's sort of think through what happens. If we do sine theta over cosine theta, we have y over r over x over r. And those r's end up canceling out, so you just have y over x. Similarly, if we do cotangent of theta turns out to be cosine theta over sine theta. These last two, cosecant and secant, they end up just being reciprocals of sine and cosine. So the cosecant theta is 1 over sine theta, and secant theta is 1 over cosine theta. And so what this does is this shows us 2 things. First thing is that it shows us that all of these trigonometric functions are related back to the same basic picture. The second thing it shows us is that these 4 new trigonometric functions are related back to the sine and cosine functions. So this shows us a relationship on how all these trigonometric functions are related to each other. So here's an example. Calculate tangent of 45 degrees. We're going to do this 2 different ways. We're going to do it once using the geometric method and once using a more algebraic method. So, the geometry, tangent of 45 degrees. What are we thinking about geometrically here? Well, geometrically, we're thinking about the plane, and we're thinking about this 45-degree angle. Now, on the unit circle, that 45-degree angle corresponds to a specific point. And this is where you're going to have to think back a little bit to the special triangles, the 45, 45, 90 triangle in this case. For the 45, 45, 90 triangle, that side has root 2 over 2, and that side has length root 2 over 2. And that gives us the coordinates of this point, root 2 over 2, comma, root 2 over 2. Now that we know the coordinates of this point, we can just use the formula. Tangent theta is equal to y over x, which is root 2 over 2 over root 2 over 2. Now when you deal with fractions inside of fractions, which we're going to do a lot of in this section, you multiply by the reciprocal of the denominator, so 2 over root 2, get a bunch of cancellation. The final result is 1. So tangent of 45 degrees is equal to 1. The alternative way is to think about the sine and cosine functions and those relationships. Right, so tangent of theta is sine theta over cosine theta. So specifically, if we set theta to be 45 degrees, tangent of 45 degrees, sine of 45 degrees, cosine of 45 degrees. We can calculate sine and cosine of 45 degrees. Now, for that, you can use either your memorized values from the unit circle, or you can just do the geometry here. Either way, you get the same result. Root 2 over 2 over root 2 over 2, which is 1. So here we reconstructed the entire triangle, and here we relied on memorized values to do the more algebraic approach. So here's another example. Calculate secant of 5 pi over 6. Now there are a couple things we can do to get started. First of all, let's just figure out where 5 pi over 6 is as an angle. Now you might remember that pi over 6 is 30 degrees, so 5 pi over 6 is 150 degrees. We're going to keep writing these out in radians for practice, but 5 pi over 6 is there, which means that we have to think about what this reference angle is right here. Well, that reference angle is going to be pi over 6, or 30 degrees, and so that just completes the pi going from here all the way to there. Now we have to think about what is the value of the secant function. Well, for the secant function, we have either the formula, so secant of theta is equal to r over x, or we have secant theta is equal to 1 over cosine of theta. Now, in both of these cases, we still need to figure out where the point on the unit circle is that corresponds to this angle. You can look that up on the unit circle picture or the unit circle diagram, or we can just use reasoning and try to figure it out. Because we know the reference angle there is going to be pi over 6, which is 30 degrees. So there's a 30 degree angle, there's a 60 degree angle. We can just use what we know about these values. Let me erase that to give myself some space here. For next to the 30 degree angle, that's going to be square root of 3 over 2, and this has length 1/2. The only catch is that since we are in the second quadrant, we know that the x value is going to be negative. And so, using the top version, secant theta is, oops, let me write that again. Secant of 5 pi over 6 is equal to r over x, where our radius r is 1. X is going to be negative root 3 over 2. Fraction inside of fraction, multiply by the reciprocal of the denominator, negative 2 over square root of 3. Or we can do secant theta, or secant 5 pi over 6 is equal to 1 over cosine of 5 pi over 6. To calculate cosine of 5 pi over 1 over 5 pi over 6, we use the reference angle and adjust the sign, so that's a negative cosine of pi over 6, right? So it's in the negative direction, and that is our reference angle, pi over 6. And that leads us to the same result, negative 2 over the square root of 3. So again, lots of ways that we can think about this, and it's important to be able to think about all these different ways because they're all related to each other.